Okay, so let's go to this part of the exercise, no? About practice about rhythm mapping. So the first question is, what is the thing that I'm doing? How I know that I'm doing what I should do, okay? And usually the thing that happens is, first you enter in a workshop or a tutorial. And in the tutorial, more or less, you can follow step by step. So in the case of I2TA, as I said, the tutorial that you can follow, the good one is just this protocol, this publication. No? So if you go to this publication, I think that this, okay, this is the one. In this case, this publication first explain overall about the protocol, about the different steps, how you can follow, limitation, experimental design, and all these things. And at some point, okay, you reach the point where you have the recipes, no? Because this is kind of follow-up a recipe, it's a protocol, no? As you can see, no, when you go to these recipes, say first, map the reads to each of the samples in the reference genome, no? And of course, in this protocol, they doesn't tell you what each of these parameters means. So how do you know what these parameters mean? So you have two options. The most simple option is if they are installed in the server, okay, like this is the case, you always can write the name of the command, --help, and it will tell you all the options, what do they mean? No? So in this case, it tells you that I2TA, this is the version 2.1, and you run I2TA2, the options, then -x, 1, 2, and then the rest. And here it's explain, well, -x is the index name, and then 1 and 2 is the pairs. And then the other options, so you say, oh, for example, -p means the number of threads. And here you have a lot of different options that you can tune, as we mentioned before, that at least for the first time that you are running. So my recommendation is first time that you are running these things, just run with the default parameters. And then if it doesn't work is when you can start to go and look here, no? So how do you get this knowledge is first you go to the publication or to some workshop, you read the instructions, and then once you run the command for first time, you go there and check about the parameters, okay? So that is kind of the process. Of course, other option that you may have is if you go to Google and write something like, this is I2TA, so I2TA2, okay, and you go to the manual in I2TA2, and of course, in the manual, it will tell you what I2TA2 is and how you can run it, okay? So that is the free sources that you can get information about running the commands. Being said that, usually when you are running the commands, the most common error is first, you are not in the right directory, so the file can, the command cannot access to the file. I think that some of you already passed that level. So comes the second option. The second option is while you was learning or you was doing something else, maybe you have overwrite or mess up with one of the files that you need to work with. As some of you already wrote me an email saying, I have this error, okay? And that is a common error too. So other important thing is check what are the inputs that you have, no? So that is, in the troubleshooting, that will be the two things that I would recommend. And of course, read the error, no? It's very important to read the error and tend to understand what is the error is saying, okay? If it's saying your FASTA file doesn't start with greater than, means that the FASTA file that you are using for some kind of reason is not a FASTA file, it's something else. So spontaneously, you need to go there and check, open the file and check if it really looks like a FASTA file or not. No, it's kind of that will be the mental process. Of course, don't worry, because I mean, I'm telling you that like looks like it's easy, but it's not. I mean, this is the thing that popped to you after years and years of working with this, no? It's not a natural skill, no? It's something that you develop after some time. And let me tell you, when I was starting to learn these things more than 10 years ago, you cannot imagine the amount of time that I was stuck in a step trying to run something because I forget a comma. Okay, and I wasn't sure what was the error. Okay, and so it's quite common. So usually when you're starting to work in bioinformatics, and let me tell you that this sounds stupid, but the first thing that you learn is to read and to write. It sounds stupid, but usually our brains, the thing that happens most of the time to our brains is that our brain complete the information when it's reading. And sometimes when you write something, you forget something and still your brain, okay, put the comma even if it's not there. So as I said, first, when you're starting to work with bioinformatics and with these skills, one of the first things that you do, or you develop after one error after another, is really to read these things, okay? So don't worry, because you feel that very frustrated because of this, it's that, okay? It's in the development of this skill. In some ways, the frustration in bioinformatics is like when you are starting to do some sport, some exercise, and you feel that your body say, come on, really? So it's that, okay? So don't worry, because the first steps are usually quite frustrating in that sense. Okay, being said that, so the first thing that I need to do is I have here. Yeah. So this will be the step. So the first thing that I need to do is generate the I2TA2020 index. Okay. So let me go to a place. So let me say here, Encadir, for example, references test. Okay, so let me copy from references the reference. So now I should have the reference. You see that I always write ls with lh because I always test what is the size of the file, no? To be sure that I really copy the file that I wanted. And also I need to copy the...
Sorry, your screen is freezed.
Sorry?
Your screen is freezed. I cannot see what are you doing.
Okay. So let me, it's freeze. Oh, yeah, sorry.
No, it's okay, man. Thank you.
Yeah. Sometimes the problem is I have a Mac, and sometimes it's starting to do backups when I don't want the machine to do backups to the time machine, and then froze the connection. So okay. So now I have the two references that I need, that is the GFF file and the FASTA. So let's suppose that you have downloaded them from a database. So the first step is I2TA build and the name of the reference, and then the base name for that I want to use for the output. So in my case, I always like to put the same name than the reference, but without the FASTA. So if I do this, okay, so it's starting to run this. It should be quite fast with the Arabidopsis gene. Usually, other thing that I found that sometimes also is a source of errors is the impatient, okay? And let me tell you that sometimes you run a program and you think that the output is going to be automatic, but it takes some time for the program to run, okay? So you need to wait. And for example, you are running a genome assembly. Usually it can take between 5 and 10 days until you get the output, no? So depending on the kind of programs that you need to run, it's going to take time. And I say that it can be a problem because a few years ago I have a student that she was really impatient. Okay, and she was so impatient that she was trying to run a program. I think that was mapping a file. The thing that happened is that she just wrote the command, push enter, and because she didn't saw, and of course she was using, this was an old server with 64 cores, and she was using 64 cores, okay, because she wanted to run these things as fast as she can. So she just click enter, wait 5 minutes, and she didn't see any output. So she thought that she thought that she was doing something wrong. So she will run the command again, wait another 5 minutes, and see that nothing was produced. So she will run the command again. And in 30 minutes, she ran the command 20 times. So imagine 20 times for a computer of 64 cores. So means you are multiplying the load of the CPUs 20 times. Okay, so it was equivalent to run around 1,280 cores at the same time, no, 1,000. So of course the server was completely overloaded, overheated, because when the CPUs are working too much, sometimes computers, especially old ones, can overheat, and then the computers just crash. Okay. So almost she fried the computer because she was kind of very impatient. So yeah, keep in mind that you need to wait sometimes, no, until the program is done. How do you know that the program is running? Always, well, you can type top and see if you really are running the program. Okay. So being said that, first part of the exercise done. I have here my my output. Okay. So second part of the exercise, mapping with I2TA2020. So I need the index and I need the reads to map. And the command will be something like this. Why I'm piping, the reason why I'm piping, as I told you before, is because I would like to get the output of this and fit into the next command, saving me some time. Okay, so that will be, I can go to cell2 processed reads. So these are the commands. So the thing that I will do is I will run I2TA2020.p, let's say 60, because I want to put in this example as fast as I can. Then -x. -x is the index, so I have my index 2, no, 3, no, sorry, 2, no, 1 directory up, and then 00 references test, and here will be just the base name. Okay. Remember, I'm using the base name. Even if I have so many of these files, I'm using only the base names of those. That is the one that I used when I was running the command. Then I have -1, and -1 will be one of the files. -2 will be other of the files. The second pair, remember, R1, R2, and then I would like to pipe this in some tools, view -F4, because I want to filter everything that has not been mapped. S, because the input is sum. B, because the output is going to be BAM. -O, and then the name of the output, that will be, for example, the name of the sample. I can remove Q30 and 50 and then put here BAM. Okay. So I think that this is all. Probably I'm forgetting the DTA. So let me see. No, here in the presentation.
I'm sorry, why the last dash?
The last dash is because some tools in order to, so there are some tools that you don't need to add the dash, and it's going to get as an input the standard input, no, the flux that come from the previous command. But in the case of some tools, you need to have the dash to indicate some tools that the input is going to be a standard input that comes from a previous command. Is to redirect the input inside the program.
Okay, thanks.
Yeah, for some reason, some programs doesn't need it. Like for example, Head doesn't need it, but with some tools, yeah, it needs it. So as I said, yeah. Now we need DTA. I'm not sure for the one that you said that you're making wrong. Check the output. Maybe the output is right. As I said, this maybe was an old version of some tools, and the new version they corrected. As I said, I don't know. But anyway, okay. So I'm running the command already. One thing that, sorry, I'm going to stop it first. Yeah, one thing that also I wanted to add was a summary file. I like to have the summary file in some specific. So yeah, if I'm not wrong, no, sorry. This one, summary file, and then let's call this R24 rep1, and then I2TA2020 map.summary.txt. Okay, so now I'm running the program, and it will take, I don't know, maybe 30 minutes, well, 10 minutes or something like that. Several things. No, I'm running this. I'm going to go to a different window. Okay, and just to be sure, let me check. This is okay. This is running. So let me go to process the bit again. So meanwhile, that is running, and you can see now how I know that this is running, because when I go to the directory, I can see the BAM file here growing. Okay. So I can see 78, 100. How much will be? I don't know. I mean, I know because I ran these things before, so I need to go to 4 gigs until it's finished. But this will finish when the summary output is waiting. Okay. So I know that it will not be done until that. Other option is I can go and check in top. And yeah, I can see myself here running a program. So that would be another way to check that really the program is running. Okay, so we are mapping that. Let's leave that in mapping before we go to the next section. But then we are going to go to the start at the same time, no? Because I would like you to, in parallel, explain to you about the other way to map. So we have here our reference directory. So first, let's create the reference for start. By the way, if you know what DTA is, so you say, okay, I was running HiSat2 and I wasn't sure what DTA means. So you can print it and say here, no, DTA. Reports alignment theory for transcript assemblers. So basically, I'm reporting the alignments in a way that is going to allow me after run a string type. No, it's just that is the only thing that means. And again, if you don't know about how a command works, you always can check the manual or okay, so we are going to leave that running. That is still not down. So with start, the thing that we are going to do, of course, you can use a start, a string type, and command run if you want, okay? So the downstream analysis, you can use whatever you want. But I thought that was interesting to have a different comparison using HT SecCount and DSec too, okay? So that will be the process. First, we need to index the genome and then run start until we get the mapped reads. So one of the problems is that the start need to have a GTF file, not a GFF. So the first thing that we are going to do is we are going to transform GFF in GTF. So, okay, this is our directory. So we are going to use GFF read -t. -t means transforming GTF. -o is the output. So I want to use the same name for the output, but instead GFF, I'm going to use the termination GTF and then the GFF. I do this. That should be quite fast. Okay, so now let's check. Yeah, we have a GTF. And as you can see, the GTF file is much smaller than the GFF. The reason is that if I go to the GTF, sorry, the GFF, this is how it looks like. I just printed the first 10 lines. So you see that we have genes and we have a lot of information in this gene. Meanwhile, the GTF is a much simple file. I only have transcript, exons, and CDS. And in the transcript of exons, I have transcript ID or gene ID. So it's much, much simpler. Okay, so first step is done. The second will be to create a directory in which we are going to start the indexes of star. So let's call this mkdir. Again, we are going to call this I2TA genome, but here we are going to call this star, for example, index, EDX. Okay, so this part is done. And then we are going to run start, but in the mode to create the indexes. If you are thinking at some point to copy and paste, if you can do that, be careful because when you copy and paste, some of the characters may change. Okay, so especially the ones that are, yeah, especially the ones that are just arrows and so on. Let me see, edit, select all. Yeah, I can select all. Select all. Okay. So for example, if I copy and paste this, I can go here and paste. And of course, during the pasting, yeah, because it didn't paste everything together, it's giving me errors. Okay, so a star is fine. Then I'm running this with 8 threads. It's fine. Run mode genome generate. It's fine. Then genome directory. So let's start with completing the genome directory. Is the directory that I created before. This is I2TA genome, and then start index. Okay, so that is my directory. Then is -- genome files, and then my FASTA sequence. So that will be I2TA genome.FASTA. Then I need to add the GTF file. So my GTF file will be ports GTF, and then the last one. Okay, and keep in mind that, of course, if I run this, it's going to give me an error, and the reason is because, as you can see, instead those 2 dashes, I have just a big single dash. Okay, that is a common problem that happens when you are copying and pasting from one file to another. Okay, so be careful when you are doing that because sometimes you may have these problems, but it's as simple as fix as replace that. So if I do this, it should start to create the index. Question that you may have until this point. Let's check. The mapping is still running. Perfect. So so that is this part. So let me finish this, and then I will start to run the star mapping. Star is much faster mapper, okay, than HiSat, so should be done before. How many of you, and you can raise hands. Well, I already have 2 people that has with the raise hand during the whole class, but so please go the hand down and then answer this question. So how many of you were able to obtain the final BAM files for HiSat? Oh yeah, so if you go to, so you have in the screen, you have close to the chat, you have the icon of people, show participants. So you go to show participants. You will have a list, and then you have a hand, and then you can raise your hand if you want, I think. No? Oh, no, also you have the icon raise your hand, okay? So in the middle of the screen, you have the icon of raise your hand. Perfect, well, I see 10 people that already got 11, 12, perfect. Happy to see it. So yeah, wonderful. At least 1/3 of the class was able to run this. Okay, how many of you were able, so hands down, perfect. I love it, perfect. So how many of you gets the start BAM file? Okay, I guess that some of you are still running it. Perfect. So no, happy to see that. Yeah, this is working. Okay, so these have already finished. So let me map. Go. I'm trying to map start. So let's go back to my processed grids. I already created the indexes. As you can see, these go for 2.7 for now. So this is still growing. So let's go to here. I'm mapping with the start. So this is the command that I propose to use it. Again, as an input, you will need to have the start index and then the reads to map in the FASTQ format, no, as before. So this is the command. So let's keep simple. Let's copy and paste. Remember that we are going to copy and paste, and then because we have breaking lines here, it's going to give me an error. But at least I will have everything in the same screen. Okay, perfect. So let's go to the first one. That is this. So it's start run thread 8. Let's keep, because this is an example, let's put this to 60 to do these things faster. No, let's keep in 8. The reason that I'm keeping in 8 is because a start can give you some problems if you use too many threads, because open a lot of files at the same time. So you need to change some configurations in the computer. Okay, so let's get the indexes. So that are the ones that are in 00 references test, and then here in the one that says start indexes. Okay, so we need to indicate only that directory. And now our read files in. Let's take the first read files. So let's say C24. Okay. C24 rep 1 and then Q3050 R1. Okay. A space, because this doesn't have -1, -2. You need to put 1 and then the other one. Okay, so I put R1 and R2. So first that's first pair, second pair. Now out file prefix. So we are going to call this ARSA24 rep1 And we don't want to confuse this with HiSat, so let's call this start and then lowercase because it's going to add more names after. Okay. Perfect. Now it's dash dash. And because the input files are zipped, we need to add this. How I know that? Well, because I read the manual. It's not a secret. Okay. And then finally, the thing that we want to have is the output as a BAM and sorted because that will save us one step. Okay. So if we do this, yeah, this is starting to run. So that is the mapping from start. Question that you may have to this point.
I haven't understand the minus at the command sort, so BAM sort.
BAM sort.
No, the minus at the end of the command.
Here, let me see.
Yes, I haven't understand the. Yes, I haven't understood the meaning. Sorry.
The meaning is telling some tools to be prepared to receive the input from a pipe.
Okay, okay.
Yeah, it's
okay.
that. Otherwise,
wait until the input is come to the command.
Because if for some kind of reason this is a program that you don't add this dash at the end, SAMTools is going to wait to have some dash I that is the input. Yeah. That's
okay, thanks.
Okay. So let me see. This will be running. This is still running. Okay. So meanwhile, I can. So we already know what is the output. I already ran this. I have the output. So let me go to the last step. That will be just to run a program to tell us how the output. Okay. So I'm going to access to the server again. I'm in the server already. So storage, users, I will seek, boom, Marelli, mapped reads. In my mapped reads, so the thing that I did is, of course, when I was running these things, in my case, I put everything in a different directory. So it was, okay, was for me more easy. So let's go to HiSat. So these are all my HiSat files. So you can see all the BAM files here. And the first that I want, so I make the mistake here that I didn't have the summary. Okay, so my summary is in my screen. So let's go to the screen. I don't think that I deleted. If I deleted that, okay, I will need to wait. Yeah, so that will be one of these examples. So this will be the classical output, as I mentioned before, of HiSat. Now it's telling you, okay, so this is the overall alignment rate. Nothing else. I don't know nothing else about here, but that will be kind of one of the summaries. So we want to run BAM tools, stats. And why I like BAM tool stats, and by the way, I did this mistake, it's not just the file. If I do this, it's going to fail, okay? Because it's a unrecognized argument was found. So yeah, probably I'm running this in the bad way. So it told me, okay, type BAM tools help stats. If I do this, it's telling me, yeah, by the way, yeah, you need to use -in. So I go back. I add the -in. Wait. In theory, FunTools is faster than, for example, SumTools. So it should be fast enough. Meanwhile, this is running, this is still running, and this is still running. So one thing that happened with bioinformatics is when you run programs, you will need to wait. No, so other skill that you develop is to do things in these intervals. So sometimes, yeah, you are running 2 or 3 or 4 things at the same time. Okay, so this is the output of BAM stats. So it's telling me that because this file was already filtered, that I have around 55 reads. Okay, because remember that we are mapping 2 pairs. Okay, so we have 52 reads. More or less the same amount of forward and reverse. We don't have LQC or duplicates. It's telling me the number of the pair reads, of which it tells me that proper pairs is 97 and both pairs are this. Why is that? Is because when you are mapping, sometimes you have a small percentage of reads that you only are mapping one read but not the other one. Okay, that would be in this case. Keep in mind that I'm mapping an accession that is C24, that is a different Arabidopsis thaliana accession. So maybe this could be a divergence compared with between 2 different accessions. Okay, so that will be the solution. Okay, so that is my stats BAM for I2TA. If I go to start, these are the files for start. Start give me a lot of different outputs, and one of them is this final out that will be similar to summary. So if I go here, this will be similar to summary. So it's telling me a lot of different information. Now in this case, uniquely mapped reads number is looks like it's much smaller. Okay, percentage of uniquely mapped reads 88. So as I said, you can go to all the different stats that are quite complete. Okay, basically when I go to mapped reads, it's telling me that yeah, the percentage of mapped read is around 1.12%. Okay, but I want to compare these 2 outputs are different. Okay, one of them is the summary of I2TA is different from the summary of this, and it's the reason why I want to use the same tool that it will be BAM tool stats. Of course, if I want, I can redirect the BAM tool stat into a file. No, that is a possibility here too.
Can I ask you a question while the program is running?
Yeah,
actually, when we were generating the star index, the line with genome, assay index, and basis, which was specified as 12. Well, I was the one of those that actually didn't check the double dash, and so probably the program assumed that it was the default values of 14 and returned an error. Still completed the thing. I didn't care,
yeah.
And I probably ended up with something a little bit messy. But I wanted to ask, what is that parameter? I mean, the genome assay index and basis 12. How do you specify it?
Okay, so for me it was simpler. When I was running star with Arabidopsis for the first time, it returned me a warning that say you are running this with the default value that is 14. Depending on the size of your genome, I recommend that instead 14, you should use 12. So I just follow the suggestion.
Ah, okay, that's that's a little bit simpler than I thought. Okay.
Oh yeah. No. I mean, yeah. Usually, as I said, the first time that I run these tools with the default parameters, and if at some point the tool is telling me do something, I do it.
Okay, cool.
If
Thanks.
I don't get the right answer, then is when I go back and I start to do the tuning. But the first time that I run any tool, I need to run them with all the parameters by default to really be sure that everything is working.
Okay.
Yeah. Okay, so now let's go to this. No, this have mapped a total number of reads of 56.48 million. Okay, 56.48 million. And here we have 55.25 million. So we can see that start has a slightly higher number of mapping rings. So just when we are comparing these two tools, start and HiSat, start looks like it's mapping more reads. So that is good. But that is not unexpected, okay? Why is not unexpected? Is because remember that in the presentation, when we were looking for mapping reads, I put this paper in which tells you that by default, start map more reads than HiSat. Even with that, let me tell you that this is not our reality, okay? Our reality here is say that stats was mapping around 30% of total bases. That is not our case. We were mapping much higher percentage. And here, this is telling us that Star was mapping around 80% of the bases. And again, this is not our case either. In our case, we reach almost 97%. Okay, so also be careful when you are looking for these papers, because maybe the data set that they use is not the same that the one that you are using. So you still should expect some differences. Even with those, as I said, my preference here would be to use a start, because you have a slightly higher number of bits. Okay, so HiSat finished. This is the output of HiSat. And in theory, we also have the summary that is here. That would be the same. The last thing, remember that meanwhile, start is giving us the output sorted. HiSat doesn't. So we need to run a last command that will be some tools sort -o. And we want, in this case, we are going to put the same name of the input than the output. Is the one of the few cases that you can do that. And the reason is because it creates some intermediate files. Okay, so that is my sort command. So I just going to sort it. Excuse me. As you can see, start already finished, so it's much faster. So it produced more reads and it's much faster. I have my BAM file here. So you see, while I'm sorting, in the sorting is creating these temp files. So this is okay. This is a temp files that some tools sort need to create in order to do that. Okay, so we have here again our BAM files with the finals and so on. So we don't need to sort it. So at this step, yeah, we just finished this part. Questions that you may have about this part before I close the recording?
Is there a particular reason why these two methods are different? I mean, from a point of view of time, or?
The algorithms of mappings are different. So the thing that usually happen, I mean, this is like, it's like, well, most of you are molecular biologists. So you have been doing, how many of you have been doing cloning? Okay, I can see some hands. Well, even better. How many of you do PCRs? Okay, so a lot of you are doing PCRs. Okay. So last time that I was in the when I was in the US, I have some part of the lab that was experimental, and I remember that I had one student that he was doing some PCR. You know, at that time, the technician that we have in the lab was in charge of buying everything for the PCR and so on. So the student came to me saying, well, the PCR is not working. And I said, did you add all the DNTPs? And he said, me, what? Yeah, if you add the DNTPs, when I was doing PCR on my time, we needed to add all the DNTPs one by one. No, you add T, then you add IA, because that was not mixed at all. And he looks like I was talking in a different language, no? Of course, now that most of the people that do PCRs now, they have these kits in which you only need to mix 3 things and it's all, no? Everything is mixed there. So having really an improvement and technical improvement in the kits, even if the PCR is the same, you have this improvement. So with bioinformatics pipelines, is the same. So at some point, you have a pipeline, and some people use some algorithms, and maybe a mathematician develop a new algorithm, and then there is a bioinformatics group that think, oh, that is great. Let's try this new algorithm to create a new tool, and you get speed, and even you can get sensitivity. So yeah, it's the reason why you will find a lot of different tools and a lot of different tools with different parameters. One part of the life of the bioinformatician, it could be, and I have been done sometimes that, people every year or every 2 years, people produce new tools or produce new version of tools, and you can just create a paper, just taking some data and simulating data or real data and running different tools and check what is the best one. Okay, it looks like it's not much science, but imagine that every 2 years, someone take all the PCR kits from the market and put all of them in the same conditions, run all of them, and it's going to tell you which one is the best and the cheapest. So yeah, so that is a big part also of the bioinformatics field, no? Compare tools and see which one is the best. So that is why we are moving forward to these things. So why this faster start? Well, it's newer and they use new algorithms. If you ask me which one, no idea. Okay.
Yeah, thanks.
Yeah.
Please explain also why the outputs are slightly different in terms of a number of forward and reverse strands. Okay.
Yeah. Okay. So being said that, I'm going to stop the recording.
I have a question too. Sorry.
Okay.
My sorted BOM is 2 gigabytes less than the normal BOM. It is normal or?
May not. So one thing that may happen is if it's for some reason the process stops, the BAM file is going to be smaller.
Okay.
How that thing happen? Well, maybe you was kicked out of the server while the program was running, and then the program stopped it. Is why you need to run these things with the start sometimes.
Okay, thank you.
Yeah, other thing that happened to me, and